sure it's not going to fall.
Yeah. Well, I'm not sure, but I just don't care. So.
Good evening, everyone. Happy Knicks celebration parade day, if you like that. As a Heat fan, I guess my response is I'll see you in 10 years. Anyway, thank you so much for spending your evening with us here at Trail of Bits. I'm Angelo Saraceno, co-host, and over there is Phil Ian. We have two wonderful talks here for you today, but first some housekeeping. This place is wonderfully supported by Trail of Bits. I'm not sure if Dan Guido's here or no, but the usual disclaimer is if you're really into really nitty-gritty kind of like I guess like low-level systems level work, Trail of Bits is hiring. You can speak to any of the folks here. They can tell you how it's like working there. So without further ado, get right to the talks. We have two speakers here. We have Olivia and Doug. They're going to be giving you some wonderful talks about. One is in this case Apple systems. Olivia will fill in that for the rest. And Doug, I believe you're going to be giving us a talk about like software quality testing. Is that basically
distributed systems fault tolerance?
Distributed systems fault tolerance. I've been totally underselling that. So Doug will help you there. That said, without further ado, give it up for Olivia.
Thanks. All right, yeah, so hi everyone. Thank you so much for having me. My name is Olivia Gallucci and I work at Datadog. Today, I want to show everybody a vulnerability research AI workflow. So yeah, before we begin, I want to mention a very simple tool that I published. It's called OSS Sensor. OSS Sensor generates a prioritized evidence-backed research queue, and it's derived from Apple's open source diffs, basic binary features, and log templates. It applies custom rule-based scoring and reporting to support triage. And you might be wondering, what's up with this custom rule-based scoring? Well, it's based on you. So you can use what I do, right? Or you can know what type of vulnerabilities you normally look for, the type of thing that you find very easy to fix and find and all of that, and you can adjust that scoring based off of what that you want to look for. So the binary and log analysis components are intentionally lightweight, and there's no integrated LLM or vulnerability verification. It's designed as a triage and hypothesis generation aid, not as some tool to develop an exploit. There's currently two versions of this project. As you can see, they look identical. One without built-in AI and then one with AI capabilities. The non-AI version is more streamlined and significantly easier to adapt if you plan to integrate your own AI workflow. I strongly recommend this approach. It's what I do and it's what my friends do, particularly if you intend to iterate quickly or vibe code your enhancements. This way, it's personalized to your setup and it won't be dependent on how I set it up. That said, the PR for plug and play with AI is still under review and testing. That's because parts of my workflow, which this talk and tool is inspired by, include intentional manual intervention steps. While I was developing this process, I quickly learned that certain configurations become costly depending on how it's set up and its usage. So I'm unsure who might really want a plug-and-play AI version, and we'll talk about that later. This is especially the case if you consider yourself a beginner when it comes to VR on Apple's operating systems. So if you'd like to explore this tool, there's two built-in demos available. When connected to an AI coding agent, the tool will outline the required execution steps as normal and then demonstrate the scoring and weighing out of the box for the three components of Apple's OS that I have already shoved in there. So yeah, and then from there, you can incorporate your own AI workflow. Given the tool's simplicity and modular design, this should be achievable within like one prompt, and you should be able to set it up from there. This talk now we'll cover where AI has helped me in my research process and how I've influenced AI to better suit my needs, given that around a year ago, ChatGPT at least could not actually tell you where logs were stored on macOS. So yeah, in this talk, we're going to talk about two vulnerability research components, one of which is reverse engineering and the other of which is fuzzing. So reverse engineering is inferring how a compiled system works from binaries and runtime behavior, while fuzzing is automatically generating and mutating inputs to exercise the system and surface bugs via violated invariants. My workflow tries to automate these steps in areas that I have found to be most reliable. First, the AI workflow treats Apple's open source code as a sensor. A sensor is any data source that produces signals about a system's state or change without doing any of that interpretation for you. Second, The workflow then uses AI agents to turn that sensor into a prioritized queue. So things like what changed, what looks security relevant, and what to reverse and what to fuzz. For context, an agent is a system that can take goals, select tools, run steps, and then produce a structured output. The problem is that Apple ships a huge security surface area, but only some of it is open source. For example, Apple has over 400 open source repos, but these releases are often incomplete and are very hard to keep up with manually. So my time is limited by bandwidth. So the story I'm going to tell is diff to hypothesis to harness. And the trick is that we augment open source diffs with two other signals, which is binaries and logs. Now, I want to address the elephant in the room, which is Apple's secrecy. So Apple actually open sources a lot more than most people expect. So the X and U kernel, core libraries, libsystem, libc, libdispatch, and historically some daemons like launchd. But they don't publish everything, so some components are missing or only partially available, so things like Core Foundation, CF Network, iOS-specific drivers, pieces of Dialed and Core Crypto, which also comes with additional redistribution constraints, even if you get access to it. Also, source drops that can be incomplete or outdated. You'll see headers referencing files that don't even exist, or build instructions completely missing. And for context on these constraints and why this workflow matters operationally, self-shout out here, I recommend watching my B-Sides 312 talk, which I gave a couple of years ago, where I talk about the history and the manual version of the process I'm about to describe. So what does this have to do with AI? Well, this information overload with Apple's 400 plus open source repos is exactly why agents help with this. If I rely on a human, aka myself, doing manual repo exploration and one-off diffs, I end up with a very narrow view of risk. If I automate that bookkeeping, I can spend more time on the parts that AI isn't working well for me yet, which is reasoning about privilege, boundaries, and exploitability. So I've even found this helpful for threat detection engineering. This matters because the faster I can understand what changed, the faster I can build detections and prioritize how to build around new attack mechanics. So even though the code is incomplete, it can still guide my research. And the key is for both me and AI to treat this like a map. I might not have the full territory, but those landmarks are real. And what I do, and what many researchers do, is use Apple's open source code as a reference while working with the proprietary binaries. You take a binary like launchd, syslogd, or a driver, aka all the demos I have in my tool, and then use whatever source exists to match known functions, annotate call patterns, and then reverse unknown logic. So this agent angle, it's pretty simple. In this hybrid method, it is effective, but it doesn't scale well. So like agents, they can do those like repetitive steps. It can correlate symbols, chase string anchors, retrieve relevant source context, and produce human summaries that would make a human more consistent and reliable. Even when symbols are stripped though, structure plus string constants plus syscall usage, lets you map back to open source code, and it does so pretty reliably. And 4 common tools that you've probably seen before show it consistently in this workflow. So first, we have strings. This gives you debug messages, format strings, and file paths. We have what, which can extract version and project info. And then there's nm, which lists symbol names if they exist, even in like unstripped binaries or frameworks. Then there's class dump, and this is great for interface information, especially private frameworks and Objective-C method surfaces. And when I'm trying to map binaries to source projects, I also use Apple's distribution manifests. To do this, the reason why I do this is to cross-reference components per release, and that's because Apple's internal naming scheme and the public naming scheme has gone back and forth and like all these crazy things for years with code names, with numbers and all of that, and they will change at times where you'll see, iOS 26 referenced 10 years ago when it just came out today, and that makes no sense. So the thought is that it's a typo, but you never know, they could have been planning that. But anyways, all of these repetitive but context-dependent steps are the exact operations I hand to an AI as context. I don't want this model inventing facts. I want it to call strings, parse that output, and then retrieving the corresponding source chunks, and then producing a bounded conclusion with citations to what it observed. After this, I usually want to go deeper with something known as binary diffing. This is comparing binaries before and after a patch to identify changes. So here is my favorite example. So in 2016, OS X Reverser used diaphora to diff syslog-d from version 10.11.2 to 10.11.3. He found that only one function changed, and that change was an allocation math fix, which was value plus 4 became value times 4 plus 4. From an exploitation mindset, that is suspicious because it looks like a heap overflow mitigation. And there was a string nearby that said add lockdown session realloc failed. And that was a hint back to the source. This kind of surgical diffing is how vulnerabilities get reversed after a patch. And it matters because fixes often need to be applied in multiple locations. If identical code is patched in some files but not in others, the unpatched ones can remain vulnerable. And the larger and more bureaucratic an organization is, you better bet there's going to be repeat mistakes in neighboring files. So imagine we take this exact AI workflow running continuously on every Apple release. So it would ingest new OSS tags and tarballs and distribution manifests and compute diffs at the function and semantic level. Then it would score changes. I'm so sorry if that was my Discord. But anyways, yeah. Then it would, then it would score changes for security relevance based on patterns like allocation math, bounds checks, entitlement gating, XPC parsing, and then IOKit external method table changes. It would correlate to binaries and string anchors, then emit a ranked queue for and say like why this looks risky, plus pointers for a human to validate. For my solo offensive research, this was a throughput multiplier. That said, I've only tested this on small individual components, never on the full OS, but I think it would be awesome if I could expand it to something like that. And just as this is kind of the big reveal of the presentation, but I spent over $3 grand in 1 month doing the data processing on Apple's open source code, and that's why I was like, oh, your plug and play with, an AI key probably isn't smart because your bill's going to be really high. So yeah, but anyways, from an organizational standpoint, this would compress that loop from, Apple just shipped something to we've identified the shifted behaviors and surfaces so that we can adjust focus, monitoring, and triage faster. And I'd imagine if this workflow was scaled, this would be the kind of workflow you'd see from like a dedicated vulnerability research group or team that tracks platform changes as a routine operation rather than a random, 23, 24-year-old with a computer. And that's why I think this is worth discussing openly, because it keeps vulnerability discoverability accessible to the junior engineer, which is me. So here's the architecture I've had the best results with. So first, I use an agent pipeline approach, which you probably could have guessed. This means that I am using a coordinated set of tool-using agents that turn raw inputs, so diffs, binaries, and logs, into evidence-backed outputs like ranked triage queues, hypotheses, and fuzz/telemetry plans. I start by using a retriever. So this is the indexing layer that searches embedded information like OSS code, notes, and log templates to return the most relevant context for a given question or artifact. Then I use a toolbox, which is a curated set of deterministic analyzers and system commands, so like strings, OTool, class dump, etc. The agents then, call together facts and generate evidence instead of guessing. Then more agents handle it. So I use different agents for diff triage, RE context, hypotheses, planning, and analysis. And unfortunately, I'm unable to tell you which ones are most effective, but I'll explain more on how I account for that later. So I don't really treat the model as like some genius thing. That's why I have it do all this like fact checking stuff. I just treat it as something that can help me work faster. Of course, there are tons of models now that can find these vulnerabilities. I haven't seen them. I don't have access to them. I'm a normal detection engineer. But like the Mythos and all that stuff, I was told that those things are pretty good. I just haven't used them, and I don't get access to them, so I'm never going to be able to know. But yeah. But anyways, I treat it, as a process that can read really fast, follow procedures, generate structured output, and hypotheses that we can validate with reversing, tracing, and fuzzing. Additionally, it's important to remember that each step in itself can break, and they're all depending on each other. Thus, your setup should ideally account for that, since you might be on a paid personal plan with limited resources. The big addition to this talk versus the classic I used Apple OSS to reverse stuff is logs. Unified logging gives you subsystem and category labels to map back to components, so stable message strings that you can hunt in binaries and source, and then execution hints that you can use to reconstruct data flow diagrams without full source. I treat unified logs as a pivot into attack surface and code paths, not as some sort of doctrine, because of bulk in macOS logs that I don't know how to deal with. And for reference, if you run standard unified log on your macOS machine for around 1 second, you will have around 100 unique and distinct logs within that 1 second. That's a lot of logs. That's a lot of logs. So, in general, these logs are good at telling you, which component actually handled the input, often via subsystem or category info plus sender image info, plus the error paths that fire that can reveal parsing assumptions, type expectations, and then any sort of IPC contracts. And that's pretty good ROI for target selection, harness design, and the general question of what to fuzz next. An AI agent, in general, can do 3 useful bounded things with logs. So first, it can take a log line and find where that string lives in a binary via strings and then locate its basic block and callers. Next, it can retrieve adjacent source context for those callers if it exists and produce a structured summary like the inputs, trust boundaries, and parsing. And lastly, it can feed that summary into fuzz planning or into detection engineering, like what to watch, what parameters are attacker controlled, and then what failure modes look like. And this is relevant to developing POCs as well as localized endpoints or detection tests. When your AI agent, research pipeline, learns a new untrusted input boundary or a new trusted XPC entry point, you can translate these telemetry requirements and correlation rules. In general, that's how you turn vulnerability research into coverage, only in the past we just didn't use AI, we just did it manually. The same idea actually applies to those back in the day kernel extensions. By diffing KX across versions, researchers have found changes to external method tables that surface new or patched entry points in IOKit drivers. So getting back to this agent pipeline stuff, what the AI Fuzz Planner agent produces is not an exploit unless you made it do that somehow, it's a plan. So first, it enumerates candidate services like syscall handlers, IOKit user clients, XPC services, and parsers so that you can focus on entry points where attacker-controlled inputs actually trust control boundaries. Like trust boundaries, control boundaries, trust boundaries. Yeah. So it produces a minimal test driver or harness scaffold, including the invocation path, the entitlement requirements, and expected input shape so that the target is reachable and reproducible at scale. And probably what does this have to do with at scale? The scale really just means reproducible here, because in order to get a payout of some sort, or if you're trying to get money from this, you need to be able to reproduce it on another system, because that's how it's going to be validated. Next, the AI recommends a seed strategy by extracting dictionaries from strings, mining parameters from logs, or bootstrapping from observed traffic, so coverage ramps quickly instead of just mutating from nothing. Note that if the command is not available in the subset that I provided, you can just add them yourself or connect an AI search chatbot if you want them to find it automatically. That said, I don't really recommend allowing AIs to search the internet and then run things on your machine unless you have a dedicated machine that can handle that and all of that. And yeah, so also that seed strategy thing that I was just talking about, this is the method for selecting and generating the initial set of representative inputs that bootstraps a fuzzer's coverage and guides mutations towards high-value code paths. And then finally, we have the AI, which defines success metrics like crash bucketing, sanitizer signals, and unique stack traces so you can identify progress to turn results into ideally actionable research. So where this workflow breaks down today is when you ask for the full exploit chain. To be honest, I'm not at the point in my career where I'm finding the most crazy O days where I'm going to be a millionaire that can move to Vietnam. Like that's not where I'm at right now. Additionally, I've spent significant time, like over the past 4 years, just understanding how the operating system works and reading every bit of documentation I have. I have studied, Levin's books like front to back, all that. Like I've taken those books with me on vacation. I've made flashcards. I've done everything I can. And one of the things I really appreciate about this approach is that it can explain, because it has so much like code background and so much code context, it can explain a lot of Apple specific concepts to you in a very easy way, like explain it like I'm 5. And I think that's absolutely wonderful. And if you don't have a research pipeline that is accounting for your lack of knowledge, like I'm not sure what each person's lack of knowledge is, but at least for me, it's that historical context that can make things very confusing. Doing vulnerability research in a way that you can consistently profit off of it just becomes like really hard too fast. So yeah, that said, the models will occasionally invent steps, especially if you hook up an AI chatbot. So I personally keep it constrained with the bug class prediction, the harness design. I think these are pretty much the high value outputs that an AI can give you, and then the human will own the exploitability. That said, if you have access to like cooler AI models than I do, like go ham, like you can go do your own thing. This also keeps the larger AI models happy, given that a lot of them try to put mechanisms to lock them down, even for legitimate offensive research purposes. One of the reasons why I'm like, oh, I can't tell you which models are most effective and stuff is that I don't like to burn bridges, but I will say I've burned this bridge very publicly. I will say I used to be a huge OpenAI stan, because when I graduated college, that was when like OpenAI came out, and I was like, dude, this can do my homework. This is awesome. So of course, my vulnerability research pipelines, I was like, I love this. Like my homework tool can also help me find vulnerabilities. They have put so many security controls into this model that like it just doesn't work. So if you're gonna go try to do vulnerability research with OpenAI's public models, I recommend you don't, because I was doing that for like a year and just watch it get progressively worse. So that is one bridge I've burned, but I've already burned that one publicly. So yeah, and if you're like me and you don't fully trust your first pack instincts when an AI runs through something, I really recommend sanity checking your ideas against high quality public work that you understand. For example, Patrick Wardle has an extensive body of writing that I personally find to be very easy to understand. And I put all of the articles I really like by him into a folder, and I use that as part of like the training data, so that when the AI has responses and all that, it can reference certain things and it explains things in a way that I find to be a little bit more what I'm used to or what I can understand. And it helps me check whether or not my hypotheses lined up with his established techniques, as well as my own notes and writing. Now, this isn't wired into the OSS project yet. It's literally just a folder. I hope you guys can all create folders on your computer. But yeah, so that might be something I might implement though for people who get confused. But yeah, also credit where credit's due. I intentionally licensed OSS Sensor as GPLv3 because I've learned a lot from GPLv3 license work by Patrick and many others. I'm kind of a GPLv3 stan, so just putting that out there. I think keeping code shareable helps others build and learn in the same way. And if you're someone who really benefits from open work and all of that, I recommend making your projects open too. So yeah, the TLDR is that even partial source is powerful. If you combine it with binary analysis, you can reverse Apple's systems with surprising accuracy. But there are constraints. There's incomplete releases, obfuscation, and licensing, and you need a pipeline that is compliant by design with local indexing, careful handling of source drops, and provenance tracking so that you can explain every conclusion. All that said, what do we learn? Also, my animations aren't showing. That's so sad. Okay, anyways, the core idea is that I want to leave you with is that Apple's partial open source can be treated like a census stream. It's not the full system, but it's a steady source of change signals, and those signals can become much more valuable when you can process them continuously. The workflow I showed takes that sensor and turns it into a prioritized research queue, but with a very specific philosophy to not treat the model as God, but to just treat it like yourself. That is like, I guess, more reliable and consistent and fast. The work happens in deterministic tooling, and the model's job is to stitch together that evidence, retrieve the right context, and produce structured outputs that make a human faster and more consistent. And that's why the narrative is diff2 hypothesis to harness. Start with a diff, source or binary, and you have to ask what meaningfully changed and where trust boundaries might be. Then you turn that into a testable hypothesis about a bug class, and it can help with size calculation issues, parsing assumptions, policy gating, or an interface surface shift. And then you build a minimal test driver, so your path is reachable and reproducible, which sets you up for fuzzing and for validation. The trick is that the open source diff alone is not enough, so we augment it with two other signals. Binaries, because they reflect the reality that ships, and OS logs, because unified logging is a good ROI pivot into which component actually handled input and which error paths fired. The fuzz planner piece is an example of how this stays practical and bounded. It doesn't generate an exploit, it generates a plan. It tells you which surfaces matter, it shows how to reach them with a minimal harness, and how to seed inputs so that coverage ramps quickly, and you can identify findings. And importantly, it acknowledges the limits. Open source releases are incomplete, binaries can be opaque, and models can hallucinate. And that's why everything is evidence-backed, provenance-tracked, and compliant by design. So again, I personally stopped throughout this process. I've utilized AI tools like ChatGPT, deep research, and given the cost constraints, manual review is required for me, especially if it looks like something I won't understand. Given these AI systems are great, but also hallucinate, and given that I might not always know what I'm talking about, it is imperative for my research to have manual checks. Finally, this is not just some like offensive research productivity hack. The same pipeline shortens the loop for localized threat detection engineering. When you can quickly identify what changed and which behaviors and interfaces moved, you can update monitoring, prioritization, and triage faster and turn platform churn into detection coverage. So these are the outcomes I care about, making macOS vulnerability research more scalable, more teachable, and operationally useful, I guess. So yeah, because I love self-promo, I can have more in terms of where you can go from here. I released an Apple security-focused newsletter called Ret to Read after I graduated last year, where I post about once a month, roughly, like whenever I actually do something about my research and work. So yeah, thank you so much for providing me the opportunity to present. I hope you all enjoyed. Thank you. Bye. Any questions? Any questions from anybody? Way in the back. Great for listening, way in the back. Thank you.
Can you also repeat the question so that everyone...
Oh, sure.
I have two questions. So one is, I know you mentioned you read like lots of books.
Yes.
Do you have any other like recommendations for other books or other resources you use?
Yes, okay, so the question was, I know you read Jonathan Levin's books, is there any other resources that you recommend or use? So there's a couple. Jaron Bradley he has new books and stuff today. What I really like about his stuff is that he includes a lot of pictures. I love pictures. And I also love how straightforward he is. My one complaint with Jonathan Levin is that I'm not the most well-educated, and he's compared code to like Greek gods and stuff, and I was thinking that those names were technical terms, and I'd Google them and I'd be like, what the fuck? So that's like one downfall to that. Patrick Wardle's work is amazing. Select Google Project Zero posts are good. I can't recommend all of them because some of them just they're like yikes, and it takes me like 5 hours to read them because of all the stuff going on. OSX Reverser is incredible. FG exclamation point, amazing. I don't know how to pronounce this guy's last name, but it's like Carol Mazouk. His profile picture is a spider. His Medium blog is incredible. But yeah, what's your next question?
I think I was just writing this down.
Sorry. Yeah.
I use Corellia. That's like my other one.
Oh, nice.
Yeah.
Wait, do I use it?
Yeah.
I do not use it. I will say the times that I've interacted with it have been amazing, and I do recommend.
Okay.
But Corellium, in general, is one of those products that can be a little bit difficult to get access to for a variety of reasons. So, yeah.
Okay.
Any more questions? Hi.
Hi. When you said the agent comes up with fast plans, can you talk more about that? In particular, how is the harness being set up? Is it black box fuzzing? How much time do you spend on each of the possible harnesses that it plans and all that.
Yeah, so when it comes up with fast plans, it doesn't come up with fast plans. I might have said that, I didn't mean that. That does not come up with fast plans. It comes up with plans faster than I could. And when it comes to how much time I spend on each harness, the way I do that is I ask myself a question. If I go down this path, even if there is an exploit, could I actually be able to understand and do it? That's the thing. And when I say like how long it takes me to vet each one, I would say around 40 minutes. If I'm not happy, like if I'm not feeling pumped about something after 40 minutes, I just let it go. I'm like, bye. Because I'm someone who, I really like the work that I do. Like this is the stuff I do outside of work. This isn't my day job. And so I know I'm gonna be doing it anyway. And if I'm not excited about it and I don't understand it, I'm like, bah. So that's how I do it. Any more questions? Also, I forgot to repeat. Did I repeat the question?
Unfortunately, no, but you're going to.
Okay. Oh well, that's all good. Awesome. What's up?
So just confirming your pipeline again, you're basically utilizing the LLM or the agent to generate fuzz harnesses, given diffs, right?
Yes, so I give it diffs, I give it lots of other, let me just pull up the picture here. So I give it lots of stuff. So in my pipeline, it has all that context. Remember, it was like, oh, I spent $3,000. Yeah. Like, so I give it that. Yeah. I give it the articles. I give it the diffs, especially if I think something is, I'm like, oh, I think I should look at this. And how I figure out things to look at is I look at what Apple's recently patched. Because Apple's a bureaucratic organization, right? Teams are siloed. And so if you see something's recently been patched, that's a really good indication to know that that patch is probably still broken. So if you have source files and stuff for that in the past, give it that. That's what you want to know. And when you, not only do you want to give it that, you want to give it the binary for what also is there. So if you have that source file plus the binary and you know that it was just in the Apple patch update, that's what you give it.
So, I mean, the question is that, okay, so, I mean, that's how you're filtering out any false positives, right? That's the first thing. Second thing is, after generating the fuzz harness, do you have like any automated setup for evaluating whether that fuzz harness is doing what it's supposed to do? Because the fuzz harness is itself a program, right? So, I mean, the LLM can go wrong in generating the code itself. There can be a lot of problems there. So, do you have like an evaluation framework where you know that, okay, this model is not performing very well, so let me switch. I need to go to a better model, or maybe it's doing really well, I can maybe scale down. So, I mean, if an evaluation framework is set up there, then that's probably a really good indication of, whether we can save costs or whatever. So that's what I wanted to know, if you have something like that.
So I personally don't. However, my friend who took this model, his name's Igor Saltykov, he was someone who was able to build out that component a little bit more, and I believe he's going to be PRing, or he might have even open sourced his version soon. And he was able, within like 3 days of when I shared my workflow with him, he was able to find like six fallings within it. And so I'd say his harness workflow is really good and much better than I could offer you. So Igor Saltykov, he's the person to check with that. He's much smarter than me. What's up?
Yeah, could you just reiterate that point? Because I think it's not like an operational insight, but it's more like a human insight about look for that patch, it's not fixed. You mean by that it's broken elsewhere, or what did you mean by that? Oh,
so it could be broken elsewhere, and so I look for that. That's kind of what I meant by like neighboring files. So like if you see, if you know a vulnerability was in this subgroup, right? And there's similar subgroups, so like think about extensions, system extensions, for example. If you're like, well, this happened over here, has anybody checked over here or over here? Probably not. Probably nobody is checked. The word doesn't seem to get around fast at Apple. The benefit of that is that you can make money. And then the other thing is if you see, subsystem X was just patched, right, for a specific problem, always just go check to see if that was truly patched. One of my favorite researchers, Csaba Fitzel, he is someone like the way that he's found like his 7-chain like O days and all that. He's like, I just go look at like all the other exploits I found because they're usually never patched correctly, and that was how he was able to like put like he got like a full chain on Mac in 1 year just by doing that. So that's did I
Yeah.
okay, cool.
Yeah.
Cool. Hey, I'm gonna have you speak right in the microphone because I don't have a good memory.
I get in the honor of it. Well, very good talk. Really enjoyed it.
Thank you.
So I had a question. I know that you don't want to burn any more bridges, but given the limitations that you have in these public models and especially around this kind of sensitive area, did you have any success, if you want to share, with open weights models and like any exceptional success that you could have gotten with the public model?
Yeah. So this sounds so lame. This sounds so lame, but sometimes when I struggle, I will copy paste the whole code. And Gemini has like good context on it, and I just paste it into Gemini Pro, and it will work.
Okay.
So Gemini Pro, you're like, create me a harness for this, do this, and I don't know where it finds that information because I haven't fed it into it. It just knows. I don't know how it knows, but it knows. So I'll say Gemini's done a really good job. I can't say I'm a huge Google stan, but they're doing something over there. So I like them. A lot of people have had good success with Claude. I don't use Claude enough to recommend it myself, but some of my friends have had really great success with it. So I'll give you that.
What about like the Quens and the Gemmas and stuff of that sort?
So my friend Joe loves them.
Yeah.
He absolutely loves them. He talks to me about. He's like, oh, you got to switch to these. Like they're not as restricted. All that. I just haven't done it. I've stuck with the lame U.S. models. So, but yeah, I've heard good things. I've heard good things. Any more questions?
I think we should.
Oh, switch. I'm sorry.
No problem.
I'm sorry.
You're good. All right. Thank you, Olivia, so much. Let's give her another round of applause. Let's take a 5-minute break and then we'll get to the